Hi, welcome to SBAC Review Day 2 questions, where we will go through the algebra and function 1 and interpreting functions. Question number 14. Match each recursive function with the equivalent explicit function. In this question, we are asked to match the explicit with the recursive. So on the left side, we have the explicit functions, and then on the right side, we have the recursive. And looks like we will first take a look at what the common difference are. So we can see that for part A, 3 is a common difference, and then B is -3, and C is -4. So we can already kind of see those over here, but let's take a look at what the first terms would be so that we can better match the questions. And when n equals 1, we have 3 times 1 plus 2, which is 5. And the next one, we will have -3 plus 8, which is also 5. And finally, we have -4 times 1 plus 10, which is 6. So we have the first terms in each one. So for part A, we have a starting term, f of 1 equals 5, and a common difference of 3, which means we add 3 every time. So that looks like it is answer choice 3. So we have A for this one and 3 for this one. And the second one is common difference is -3 and starting with 5, and that looks like number 1. So this is B and this is number 1. And finally, we have a common difference of -4 with a first term of 6, and that looks like 2. And this is C, and this is 2. So we have all of the equations for explicit match with the recursive. And that's the end of question 14. Number 15, 2 types of membership are available for a LA Fitness. The first type is an unlimited use membership for $35 per month, and the next one is a monthly $5 fee plus $2 every visit. So the question is asking for you to write an equation that can be used to find the number of visits V per month needed for the 2 membership types to cost the same amount. So an equation, that means we're going to need to have an equal sign where the 2 are going to equal. So for the first one, we have a straight flat fee of $35. And the second one is going to be $2 per visit, V for each visit, plus the $5 initial monthly fee. We're going to solve for V so we can find out how many visits it will be the same. So subtracting from 5 from both sides, we have 30 equals 2V. Divided by 2, we will have V equals 15. And so it will take 15 visits for the 2 memberships to be equal. That is the end of the question. Number 14, which ordered pair is a 16. Which ordered pair is a solution to the equation represented by the graph? So we can go ahead and graph the points to see where the points fall and which one will end up on the graph. So we have 2, 0, and then 2, -6. -6, 0 is probably somewhere out here, and then 6, -2 is here. As you can see, of all of the points, only point A, the first one, is going to fall on the graph. So the answer is A. That is the end of the question. Number 17, consider a sequence whose first 5 terms are 0, -3, -12, -27, -48. Which function could be used to define and continue this sequence? So out of 4 of them, we want to see which one is going to give us the sequence. So we probably better off just working out all 4 equations. And so we will write the equations on top here. And we will need to find the first 5 terms. So let n equals 1 through 5. And we're going to substitute each equation with the term. And So we are going to, I'm only going to work out the first couple so you know what the pattern is. Negative 3 times 1 squared, that's going to give us negative 3. And negative 3 times 2 squared, that's going to give us negative 3 times 4, which is negative 12. And if you continue the pattern, you should get negative 27, negative 48, negative 75. And then same thing here. We're going to have 1 minus 1, which is 0 squared. That's going to give us a 0. Negative 3 times 2 minus 1, which is 1 squared. That's going to give us a negative 3. And if you continue, you should get negative 12, negative 27, negative 48. And the same thing here. Negative 3 times 1 plus 1, that's 2. That's negative, oh, and I forgot the square. So that will be negative 3 times 4, which is negative 12. And this will be negative 3 times 2 plus 1, which is 3 squared, that's 9. And that will give us negative 27. And if you continue, you should get negative 48, negative 75, and negative 108. And finally, for the last function, we're going to have 1 plus 3, which is 4 squared. That's going to give us negative 16. And then if we keep going, that will be negative 25, negative 36, negative 49, and negative 64. And if you take a look at the sequence, the one that will give us the sequence right here would be the very second one right here. That will give us the exact sequence. So we know that that will be the answer for this question. So that will be the one that produces the sequence. That's the end of the question. Number 18, choose the domain for which each function is defined. So for the function to be defined, since this is a rational function, which means it has a fraction, we just basically looking for the denominator to not equal to 0, because we cannot take any number divide by 0. That's going to be undefined. Okay, so we cannot have 0 on the bottom, and that's the restriction. So we need to just basically set the bottom cannot equal to 0. So in this case, solving for x, we have x cannot equal to negative 3, and so that looks like answer choice B. Number 2, if we do the same thing, x cannot equal to 4, and the other restriction for this one is since it has a square root on top, we cannot take the square root of a negative number, so we must have x plus 3 has to be greater than or equal to 0, and so solving for x has to be greater than or equal to negative 3. So that looks like its choice. So we have two restrictions for this one. X cannot equal to 4 because of the fraction in the bottom, and because of the square root, x has to be greater than or equal to negative 3. And that looks like answer choice D. And this one is a square root function, which means the only restriction is we cannot have a negative number. So x plus 3 has to be greater than or equal to 0. So the only restriction is x greater than or equal to negative 3. And that would be C. And the last one, since we don't have any square root, we just need to look at the bottom. X minus 5 cannot equal to 0, so x cannot equal to 5. And that looks like answer choice A. And that is the end of the problem. Number 19, consider a sequence whose first 5 terms are 5, 8, 13, 20, and 29. Which function could be used to define and continue this sequence? So this is pretty much like number 17 that we did earlier. We're going to set up the 4 functions. So we need to list them here again. And that will be x squared plus n squared plus 4, n cubed plus 2, n plus 4, and 4n plus 1. And again, we're going to look for the first 5 terms to see which one will produce the sequence that is given. So when n equals 1, we got 1 squared plus 4, which is 5. And continuing the pattern, we will have these 5 sequences. And this will be 1 cubed plus 2, that will be 3, 10. 29, 66, and 127. And n plus 4, that's 1 plus 4, which is 5 for the first term. 5, 6, 7, 8, 9. And this is going to be 4 times 1, which is 4 plus 1 is 5. 9, 13, 17, and 21. So this is the list of sequence that are produced by the 4 functions, and we're looking for this 5, 8, 13, 20, 29, which means the first function will give us that sequence, and the answer is A. End of the problem. Number 20. While at basketball practice, Anthony records the number of attempts A it takes him to make B baskets. His data is recorded in the table, and the question is asking us to find the average number of attempts per basket it will take Anthony to make each of his first 3 baskets and round to the nearest 10. So if we look at this as a ratio for the first basket, his his rate is going to be 3 divided by 1. That's A over B, following A divided by B, which is going to be 3. And we have R2, which is the second basket, is going to be 6 over 2. That's going to be 3. And then continuing for R3 is going to be 7 over 3, which is 2.3. And if we find the average, because it's asking us to find the average, we will average R1 plus R2 plus R3 divided by 3. That's going to be 3 plus 3 plus 2.3 divided by 3, and that will be giving us an average of approximately 2.8 attempt per basket. And that is the end of the question. And looks like this is the end of day 2. So go ahead and finish your worksheet 2.